Hi everyone. Our research is called Studying the Impact of UAV's Adoption on the Safety Performance of Construction Projects Using Agent-Based Model. So let's start with a small introduction and background research. Construction sites are known for being hazardous in nature, and despite the improvement in the safety management practices, this industry still suffers from high rates of work-related injuries and fatalities. Now, the main reasons behind construction accidents are the unsafe conditions on site as well as the unsafe acts by workers. And this is why there's a need for a standardized observation system for these conditions on site in order to monitor the safety performance. Unfortunately, the traditional practice of safety inspection by a safety inspector who navigates the site is very tedious and time consuming. But the good thing is that the advances in technology can help us in solving this problem. Specifically, the use of drones has recently been introduced into the world of construction. As part of the safety management system, the term UAS, Unmanned Aerial System, is used to describe the system that is composed of one or more drones or UAVs, in addition to a ground control station and any other devices that can be installed on the drone, such as a camera, a microphone, or even sensors. Now, the use of a UAS on an actual construction site for the purpose of safety inspection has scarcely been documented in the literature. And this is why there is no data regarding the efficiency of the use of such a system on improving the safety performance of a construction site. And since the collection of this data needs a long time with application and not just one but several projects, this study instead employs simulation modeling in order to simulate the dynamics of a real construction site. So the main aim of this study is to understand the long-term effects of using drones for safety inspections on the safety performance of construction sites compared to the traditional practice of safety monitoring by a safety officer. So, what are simulation models? Simulation models are computer models that we can use to mimic any real life system or process. So, if you have a problem related to a certain system that we need to solve, we can use simulation modeling in order to mimic the dynamics of this system in order to find a solution for this problem. So, simulation models provide a flexible virtual world where we can create nearly anything imaginable. Now, in our daily lives, we use many kinds of model. And one of the most popular models we use is actually the ones we do in Excel sheets. So these kinds of models use formulas and scripts in order to find analytical solutions for the problems at hand. However, we have some cases that are sometimes too complicated to use Excel for. We have cases where we have too many variables involved, nonlinear influences, time and causal dependencies, counterintuitive behavior, and many uncertainties. So, for these cases, the analytic formula based solution is either hard to find or simply doesn't exist. So, this is why simulation models are perfect for these situations because they allow for easily incorporating all these factors and uncertainties. So, one of the most important features of simulation models is that they provide a free risk world that we can play and test with. So, when we have a problem that we need to solve, what we cannot afford to experiment with the real object because building, destroying, and making changes may be too expensive, dangerous, or just impossible, such as the cases when the system does not even exist yet. So we can build the simulation model that will resemble the real life system. And using the simulation model, we will find a solution for the problem that we have to finally implement it on the actual system. And in addition to this, these models can help to visually observe the dynamics of the model system. You can even visualize the model in 3D and interact with it through graphical user interfaces, for example. Now, some of the many uses of simulation models is to predict the output of a certain system, to describe how the system behaves and why it behaves the way it does, to experiment with if-then scenarios, to design and test systems that do not even exist yet, to measure the performance of a system, to use as a training tool for practitioners, to find system bottlenecks, and to design and improve processes. So, in our case, we are going to use the simulation model in order to measure the safety performance of the system. So, let's see the conceptual model that we are going to translate into the simulation model. So we have two conceptual frameworks that we need to compare. The first one is related to the safety inspection process by a safety officer, and the second one is the safety inspection process by a UAS. Now, both of these models are going to have common parts which are related to the characteristics of the project as well as the construction worker safety behavior. So as you can see, these parts are exactly the same in both models. The only difference between the model is going to be related to the safety inspection practice that will be applied. So the construction project in the model is going to be characterized by the level of risk, which is the risk probability, as well as the severity of the risk when it exists. And the construction site is divided into small areas, and each of these areas is going to have these characteristics. Now, regarding the cognitive process of the worker safety behavior, this process is completely adopted from a study by Shwa et al. And applied in the model. So the workers in the model are going to be characterized by their risk perception, their risk attitude, as well as the perceived subjective norms, which are the norms that they perceive from their coworkers as well as the management. So, based on these interactions, as well as any accidents that the worker might be subject to during his work, his safety behavior and characteristics are going to change with time. For the first case, which is the safety inspector, this inspector is going to wander the site in order to check for any non-compliance with the safety standards. And the main characteristic of this inspector is going to be the time needed to conduct this inspection, and accordingly, the number of inspections that can be done in one day. Now, based on a semi-structured interview done with safety inspectors in Lebanon, the amount of time needed to do an inspection was deduced and used in the model. And also, according to these interviews and previous studies, we note that only one inspection is usually done on the site every day. And this is the rate of inspections that was also used in the model. Now, moving on to the UAS process. So the details and the characteristics of this process are all adopted from a study by Demilo et al. A UAS consisting of one drone mounted with a camera and a ground control station are considered to be doing the monitoring process. And the project is considered to be in the concrete phase. So the assumption is that the drone is going to navigate the site externally without going into the built parts of the building. And during one inspection mission, the drone is going to inspect the site at three different levels: an overview, a medium view, and a close-up view. And this is because at each of these levels, only certain requirements can be visualized, as you can see in this diagram. Now, the area of the footprint of the camera, which is the area that can be detected by the camera on the drone, is related to the characteristics of the camera as well as the height in which the camera is operating from the ground. So in our study, the camera is assumed to be following a flat flying motion, and accordingly, the dimensions of this footprint are calculated, as you can see in this figure, based on the methods and the equations from a study by Chen et al. Now let's take a look at our simulation model in order to see the drone in action. First, we're going to have a quick tour in our construction site. So as you can see, this is the construction site in the concrete phase as mentioned, and we can see different activities happening, and this is our drone. And now we are going to see how the drone will function. So as you can see, the drone moves a certain distance and then stops for a few seconds in order to take the needed photos and videos and then transmit them to the ground control station in real time. And this process will be repeated over and over again until the whole site area is covered. And as you can see, we can see the area detected by the drone on the ground. Now, at this point, you will see the drone moving from one view to the other. So before it was at the lower view, and now it's at the middle view. And as you can see here, it repeats the same process again. But now the area that is being detected on the ground is bigger because the height of the camera from the ground is also bigger. And now the drone is going to move from the middle view to the overview, which is the highest view. And as you can see now, the area detected by the camera is much bigger, and the whole site will be covered in only a few steps. Now, according to the tests conducted by Demilo et al., they found out that only a certain percentage of the assigned requirements were able to be visualized at each level. So this figure here shows the percentage of safety inspection requirements visualized by snapshot, and accordingly, these percentages were used in the model. Moreover, the collected photos and videos by the drone are going to be scanned for detection not manually or visually by a human, but automatically by a certain algorithm. So again, only certain percentage of requirements will be detected through the algorithm based on the precision of this algorithm. Now, the details for the functioning of this algorithm, as well as its performance, are all adopted from a study by Soheila Antar, and the percentages used accordingly. And finally, the last two characteristics of the UAS that are also used in the model are the battery life as well as its velocity. So let's check out the results of our simulation model. So what we need to do is to measure the safety performance. The safety performance is measured using certain indicators. Lagging indicators such as the incident rate show the magnitude of occurrence of accidents, and they are reactive in the sense that they collect after the fact statistics. Leading indicators, on the other hand, provide metrics that monitor the process during its implementation and thus allowing managers to proactively respond to these collected results. Now, ideally, a combination of both indicators should be used. In our study, we are using the incident rate as a lagging indicator and the safety behavior and the hazards reported as leading indicators. So the first indicator is the lagging indicator, which is the total recordable incident rate. This indicator is a measure of occupational safety and health based on the number of safety incidents reported against the number of workers present and the total number of hours worked. So in order to get reliable results, the model was run for 100 times. And as you can see, this figure shows the box plots for the incident rate for the 100 simulation runs for the two cases. The first one is for the case of the safety inspector, and box plot 2 is for the case of the UAS. So as we can clearly see, all the values for the case of the UAS are less than the minimum value in the case of the safety inspector of the 100 simulation runs. And it is to note that the mean for the case of the safety inspector is equal to 3.9, and the mean for the case of the UAS is equal to 0.63. Now, the second indicator, which is a leading indicator, it's the safety behavior. This indicator shows how the unsafe behavior of workers changes with time along the project duration. So the model is run for 1 year and the change is traced. So as we can see, for the case of the UAS, the unsafe behavior of workers decreases along time with a fast rate at the beginning and a slower rate towards the advanced stages of the project. And this is mainly because at the end of the project, most of the workers will have already learned and acquired the acceptable safety behavior, bearing in mind that the same work crew is considered along the whole simulation duration. And we have a total decrease of 13.61%. Now, for the case of the safety inspector, surprisingly, the unsafe behavior of workers actually increased along the project. And this is explained by the fact that the workers are not getting warned enough about their unsafe behavior. So, as we mentioned earlier, only one inspection is done by the inspector per day. And we found out from the model that for the used site area, the inspection takes around 3 hours. This means that during the 3 hours, some of the unsafe behavior of the workers will be detected, and so they will be warned. However, for the other 5 or 6 hours in a day, any unsafe behavior will be missed, and so the workers will not be warned about it, and thus they will conceive that this unsafe behavior is acceptable, and this is why they will continue behaving unsafely. Now, this clearly shows that employing a safety inspector is not enough on its own as a safety management practice. It should be accompanied by other practices such as safety training, toolbox meetings, and feedback and open communication about safety. And finally, for the third indicator, which is also a leading indicator, which is the hazards reported. This indicator shows the percentage of unsafe conditions that were able to be detected along the project. So this graph shows the box plots for the 100 simulation runs, one for the case of the safety inspector and two for the case of the UAS. So as we can see, the percentage of hazards detected are much higher in the case of the UAS. Now, this high percentage detected despite the restrictions imposed by the percentage of visualization and the percentage of the detection by the algorithm is mainly due to the number of inspections that were able to be done per day by the UAS. So, for example, for the site area used in our model, the drone was able to conduct the inspection 8 times each day, which means that if an unsafe condition was not detected or visualized in the first inspection, there is still good probability that it will be visualized or detected in the next inspection or the next before the condition actually changes. So, as a conclusion, we can clearly see that we will have better safety performance in the case of using a UAS when compared to the use of a safety inspector. However, it's very important to note that using drones for inspection as a tool on its own is definitely not enough. It must be accompanied by a set of standardized procedures for adequately planning the flight mission, collecting and storing the data, analyzing this data, and taking the appropriate immediate and future actions accordingly.